Hey guys, I just want to make sure that we are good to go on some of the most important things that we have come across in this acid-base unit. In particular, we should have the skills to find, if we, for example, know the hydrogen concentration, we should be able to find hydroxide concentration, pH, and POH. And so what I thought I would go ahead and do is just go through two of the problems that we saw on this worksheet here, particularly problem 1 and problem 2, both that are dealing with strong solutions, so strong acid and strong base. So I'm just going to kind of rewrite these and go through them real quick. So let's try these out. Remember that both of these acids and bases are strong. And that's important because when this means that it's strong, it means that all of this is going to break down. So notice all of my nitric acid is going to break apart into hydrogen ions and nitrate ions. The arrow is going in only one direction. This goes to completion because the Ka is so huge. So that means that there will be none of this as nitric acid in solution. Instead, it will exist as the individual ions. Now, the reason that's important is because this concentration here, after the reaction is complete, will be the concentration of not only the hydrogen ion, but the nitrate ion as well. But it's only this hydrogen concentration that's important to me. So from here, we should be able to use the hydrogen concentration to find pH, POH, and the hydroxide concentration. This is my method. Since I have hydrogen concentration, the easiest thing to find is pH. So that's going to be the opposite log of our 0.0125 molar will give me pH, where I get a pH of 2.903. Well, if the pH is 2.903, POH is the easiest thing to find because pH and POH always add up to 14. So 14 minus my pH should be my POH. So here I'll take my 14 minus 2.903 and then I'll end up with 11.097, and that is my POH. And the nice thing is to find from POH, I can find the remaining thing, the hydroxide concentration. So remember, since we took the logarithm of our concentration here to find the pH, we do the inverse function, which is 10 to the negative POH, will actually give me the hydroxide concentration. It's important to note here that it's also true that you could take 10 to the negative pH and that would give you hydrogen concentration. But since we're interested in the hydroxide concentration, then we can do that. And the value I get here is 8.00 times 10 to the negative 12. Now, this isn't the only way I could have done that. Keep in mind that we also know a relationship that exists. Specifically, we know that the Kw value, which is 1.0 times 10 to the negative 14th, also equals the hydrogen concentration times the hydroxide concentration. So had I wanted to, since I had the hydrogen concentration here, I could have divided my 1.0 times 10 to the negative 14th by the hydrogen concentration, and that would have given me the same hydroxide concentration. Convince yourself by trying it that you get the exact same number. Let's try the same thing over here with our base. Now, the only difference is that this value is talking about the concentration of a strong base, KOH. So with that strong base, this concentration here means that KOH, since it's strong, is going to completely dissociate into potassium ions and hydroxide ions. So since it goes to completion in this direction, this concentration here is the same as the hydroxide concentration. So I know the hydroxide concentration for this base will be 0.0125 molar. Since I have OH, the easiest thing to find of the remaining three things, since I have OH, we've got pH, POH, and H that we still need to find. Well, to me, since I have OH concentration, the easiest thing to find is POH. So I can do that just as I did before by taking the opposite log of that hydroxide concentration. And not surprisingly, since it's the exact same math that I did over here, I'm going to get the same number. However, it's the POH that's equal to 2.903. Likewise, then it makes sense that the pH is going to be 14 minus that number, which is the same value I got before of 11.097. Remember, this is a base. The pH should be a greater than 7. Not surprisingly, I could use some of the same math here to end up finding my remaining information, which is the hydrogen concentration. Hydrogen concentration can be found from the pH. In particular, we know that it is going to be 10 to the negative pH value. So that's going to be 10 to the negative 2, or excuse me, not 2, but 11.097. So not surprisingly, I'm going to end up with my hydroxide concentration, excuse me, not hydroxide, but hydrogen concentration to be the same as we saw, 8.00 times 10 to the negative 12. But this is the molarity of my hydrogen. Hope this helped.